All right, last video here. We are going to jump into an FRQ that uses a lot of the things that we just talked about. It also uses some other things, but we'll get there when we get there. So this is from the 2016 test. It's question number 1. You are allowed/required a calculator for it. So hopefully you still have your calculator. There we go. You can ignore that. Before we do it, though, I want to go back to some slides from our last class. So, speed from my bike. What does the area, or now that we called it the integral, under the curve represent? What does the area of the speed of my bike represent? How far I've gone. Good job. Hopefully you said that. All right, next one. Answer this to yourself again. If I integrate my heart rate over the duration of my bike ride, what would that represent? It would represent the number of beats over my ride, the number of times my heart beated. All right, COVID graph coming up. This is actually the Colorado data from May, 3/18/21, so quite a while ago. Bam. So what would the area under this curve represent? Ooh, all the way out to there. It would represent the number of cases. Next question, same graph. If I only did the area from August 1st to October 1st, what would that be representative of? So from here to here. Well, I guess August 1st to October. Yep. It would just represent the number of cases between those 2 days, or between August 1st and October 1st. So what I want you to get is that an integral is area under the curve. And if it's a rate function, for example, the number of new cases per day, then it is the net change, the total number of new cases from August 1st to October 1st. All right, final time for this FRQ. You should have a copy of this that you cut out. So I will read it to you. You might want to pause and paste it into your thing. We're going to do A, B, and C. We're not going to do D. So start from the beginning. Water is pumped into a tank at a rate modeled by this. So I'm going to box this and write in rate. It is in liters per hour. T goes from 0 to 8. That kind of matches this thing up here. T is measured in hours. Water is removed from the tank at a rate modeled by R of T. Oh, R of T is in the table above, right? So R of T is shown in the table above. This is R of T. So this is the remove rate. So I'll write out rate. And they do tell me that it's differentiable and decreasing. That's going to be important for us at some point, I think. They tell me that the table has information above. Oh, and then they say starting amount. All right, V is 50,000. Okay, so part A says to estimate R prime of 2. So I would have written all this stuff before even reading part A, just to piece together what they've given me here. R prime of 2. You should know that when I do a derivative, we're talking about slope. When they say R equals 2, notice that is in between T equals 1 and 3. So how could I use this to estimate slope? Hopefully, you said, I'll make a little arrow, R prime of 2 is approximately, not equal to, R of 3 minus R of 1 over 3 minus 1, which gives me 950 minus 1190 over 2. So you could, especially because this is a calculator question, stop there, and that's a 5. It looks like an 8 a little bit because of the way my pen works. I'll fix it. There we go. You could leave it. You might type this in your calculator and get a number, but remember, we have this thing called AP form, and we can leave things unsimplified like this. And I am not going to lose points for doing that, and I totally suggest that you just leave it like that. They do say indicate units of measure. So all I got to do is think about what are the units of R? It's liters per hour. And what are the units of time per hour? You could leave it like this, or you could say liters per hour squared. Either one's good. Okay, part A is done. Cool, let's go to part B. All right, so use a left Riemann sum, left sum, the 4 subintervals to estimate the total amount removed for those 8 hours. And then, ooh, is it an overestimate or underestimate? See, they're asking that stuff from above. So, go like this. Oh, sorry. It's a little bit different from the ones we've done before because it's related to what I just started to write there. Do you see how this is a little bit different from what we did before? Ooh, this is a gap of 1. Ooh, this is a gap of 2 and 3 and 2. So the gaps, those subintervals, don't all have the same length. So when we multiply, what I like to do here is circle the ones on the left, right? Because we're doing the left sum. And 1, all right, L is equal to 1 times 1340 plus 2 times 1190 plus 3 times 950 plus 2 times 740. Now, again, AP form. You don't have to simplify it. You are liable to type this into your calculator and mess something up. So, I suggest you stop here. You're going to be like, but I want to, nah, get the points where you can, okay? So, I'm going to leave it like this. Although, in the next question, I may need it, so, but anyway, so, and then they ask, is this an underestimate or an overestimate? Well, how are we going to figure this out? How do we know if a left Riemann sum is an under or an overestimate? What do I need to know about the function? Oh, it's decreasing. So what I'm going to do is draw a little function that's decreasing with a left sum. Remember, I take the heights on the left. And look, is an overestimate because R of t, and you should write this because they said, is it an overestimate, and give a reason for your answer. So this is my reason, is decreasing. And you can say, as shown in my picture. But to be honest, that's optional. You don't have to say that it was shown in the picture. You don't have to draw the picture. Just saying overestimate because R of t is decreasing is enough from the AP's perspective. But I like to write that because I want to make sure I didn't mess it up. So let's go to part C. Remember, we're not doing D. So use your answer from part B to find an estimate of the total amount of water in the tank at the end of 8 hours. So this one, remember it started with 50,000. Now, part B, if you actually do go and add all of these up, honestly, you could use AP form, you could kind of contrive it, but if we go and add all these up, we get, I have it written down over here, minus 8050. That is the amount lost from R of t. And then plus, I need to do the amount that is added. Well, what information here, and using my calculator, stuff that we talked about earlier today, how could I do it? What information here would help me? Ooh, this is the in rate, remember? So if I integrate the in rate from 0 to 8 of W of t dt, then that'll give me amount that came in. So I got starting amount minus amount removed plus amount that came in. And for this, you just type this into your calculator. Make sure you type the 2,000. Make sure you type all this squared and the fraction and the negative all right. And if you do that, they said to the nearest liter somewhere. Nearest liter, I believe, if I did all my math right, we get 4,976 liters. Hopefully, you're cool with that. Hopefully, you're cool with everything talked about in the last 3 videos. Hopefully you took a little break in a little bbit. You have some homework. Just do a handful of other FRQs. If you have time and you want to finish it right now, finish your homework, go ahead and do it. Thank you. See you later. Bye, y'all.